So is everybody back? Let's continue. So before that we continue on the ISIS advanced features, let us just go through a bit on the basic ISIS first. Just give you some idea what is ISIS. So ISIS, as we know, that is purely layer 2 protocols, yeah, inside the TCP/IP. Okay, ISIS is run on the data link layers. So the information that is sent into the ISIS, we call it as always as a PDU. Okay, it's a PDU. So that's why when they send the link state, they say as a link state PDU. It's called LSP. So in the ISIS, we also need to know what is the method of the router IDs. How are you going to recognize that who you are under a data link layers? So they do not using 32-bit integrals. They're going to use a network entities. So they're using as a network entity. From the network entities, they're going to divide a different portions. They divide a portion of the area, okay, area followed by system ID, followed by N selectors. So they're going to combine all these three together to form the network entities, similar to form the router IDs into the OSPF or BGP. So in the area, we can start from 1 byte to 13 byte. Okay, system IDs 6 byte. Yeah, 6 byte for the system IDs. And N selector 1 byte. Okay, so the maximum is 20 byte of the network entities. Compared to the router IDs, it's only 4 byte. But in the ISIS, they're going to use 20 byte in total. The maximum is 20 byte. Okay, but normally we're using about 10 byte. Okay, using 10 byte as normal. But they can go extend up to 20 byte. But 10 byte is more than enough already. So the bare minimum they need to use it be about 8 byte. Okay, 8 byte is a bare minimum of their network entity. Why they can be in difference 8 byte, 10 byte, 20 byte is all because of the areas. The areas they can be start from 1 byte to 13 byte. Okay, system ID and N selector is really fixed for 6 byte and 1 byte. These two are fixed. Area are not fixed. Okay, area is not fixed. Area it can be from 1 byte, 3 byte, 5 byte, 7 byte. So this one must be odd numbers. Okay, must be odd numbers. System ID is fixed for 6 byte and selector will be 1 byte. And under the areas, normally we're using these numbers as a 49, 0, 0, 0, 0. Dot system ID is system ID. This is your router IDs. Okay, system ID is your router ID. This is your area IDs, which area you belong to, and what is your system ID of this area. So in the area, in the lab environment, we're using this method 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, X. And N selectors is 1 byte. 0, 0. So this how normally is representing. So in total over here you have a 10 byte. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total there were 10 byte within the entire network entities. This network entity is just like a router ID. You must define the network entity for it to able to communicate with others. That need to be done. This needs to be compulsory configured on the basic ISIS. Okay, 49000, this is your area, and this is your system ID, and this is the N selectors. N selector is always 0. N selector is always 0 when you're running on the TCP IP is always 0. This is called the integrated ISIS. The N selectors over here called network selectors. The network for the IP environment is 00. And that is your system ID to define your router IDs. You can convert from your addresses, or you can just use any number that you want. Like in the example over here, I just put 00x. You router 1, I put 1. Router 2, I put 2, and so on. Okay, this is how I define in my example here. You also can use your MAC address to allocate it from here. Just this nice 6 byte is for your MAC address. Okay, 6 byte is for your MAC address. But let's say you want to use this. Let's say you have an address of 10.1.1.1. This is your router ID. How are we going to convert this to become the system ID of the network entity? So every single octet, you just make it 3 digits. So whichever is not 3 digit, you just add a 0 in front. 0, 1, 0, 0, 0, 1, okay, 0, 0, 1, 0, 0, 1. Okay, I will just add 0, 0 in front. 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, and I cut it to, I add the dot in between. Okay, that is become your address. So your network entity will be 49, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, dot 0, 0. Okay, let's say you want to convert your network address to become your system ID. This is how we can perform in this case. Is that okay? Okay, that is on the understanding on the network entity first. And second thing you need to know is on the ISIS, on the levels. They have divided level 1, level 2, or level 1 or 2. Okay, level 1 or 2. So it can be a level 1 routers, level 2 router, or level 1, 2 routers. And the default is a level 1, 2 routers. Okay, default is a level 1, 2 routers. So on the level 1, 2 routers, what are the functionalities between these 1 layers or 2 layers? What are the difference on this? Okay, so you need to know pretty well what are the messages they're sending across. In level 1, in level 1, they send the level 1 LSP. Level 2, they send level 2 LSP. When level 1, 2, they will send level 1 and 2 LSP. They will send both. So what's the difference between level 1 and level 2? So when you're going to combine, we're going to be mix this information with your OSPF. Let's say you're going to identical compare between OSPF and ISIS. How that can be compared between these two? How to grab the ideas, what it means level 1 in the OSPF, level 2 in OSPF, level 1, 2 in OSPF. Okay, so from here I need to draw a diagram from here. So let's say right now I have a router A, router B, router C, router D. Okay, and also router E. So in this environment, let's say I have 3 different areas. Okay, 3 different areas. 49.0001, 49.0002, 49.0003. Okay, that is my 3 areas. And this is a level 1 routers. This is a level 1, 2 routers. This is a level 2 routers, level 2 routers, and this is my level 2 routers. Let's say like this. All right. Okay, level 1, 2, and level 2, they form the backbone area. Okay, they form the backbone. So it means that you can say that level 1, 2, and level 2, they consider as a backbone. Okay. So level 1, 2, level 1, 2, they also call this as a ABR. Okay. When you talk about OSPF, OSPF is called this as a ABR. Okay. Level 2, we call as a backbone routers. Okay. Backbone routers. Backbone routers. When you route level 2, you always is a backbone. When you are the level 1, 2, you are the ABR. Okay. When you are the ABR means that you have level 1 behind. This level 1 behind requires a stub routers. Stub routers. Do you know the behavior? The stub routers. What the function of stub routers? Stub routers, they will not handling all the external route they receive. They will not receive. Okay. Remember that into OSPF V2 or V3, they have a stub, totally stub, and SSA, totally NSSA. So same case on this stub routers on level 1. Level 1, they can only talk within their area. They will not able to pass through other areas. So it means that when 49001 of level 1, they cannot go direct to the 49002. Yeah? They can't go direct to the 49002. They need to go through, they must point this to the destination. So they must point this as a default route to go to the router C, D, or E. Means that router A, by right, they will not get all the detailed information from the level 2. Level 2 is the backbone. I'm just a level 1. I just stop. For me to go out, I need to send the traffic going to my default route and forward out to the destination. Okay, from level 1 router A going out to B, C, D, and E. Okay, that's why this we call as a stub routers. Okay, stub routers. Level 1, 2 as an ABR. They're doing the translation. They translate a level 1 LSP into level 2. Level 1 into level 2. Okay. But level 2 not going to level 1. No. They only translate one direction. Okay. Whichever I have in level 1, I translate to level 2. But whichever I have in level 2, I will not translate back into the level 1. That is the behaviors of the ISIS on the level 1, 2 devices. It's not like OSPF ABR. OSPF ABR, whichever I have type 1, I translate to type 3. Type 1, I translate to type 3. Yeah, that is type 1, type 3. Or the type 9 to type 3. The intra-area prefix, I will going to be convert to become the inter-area prefix. Okay, that is the differences that you might need to be aware that what are the differences between the OSPF and ISIS. So up to this point, do you see the structures over here? Okay, even though let's say I will do some changes from here, sir. Even that this routers is level 1, 2. Do you think that this level 1 can go up to this level 1? No. From here, what they exchange, they only can have from the level 2. Level 1, they will not able to pass through other areas. They only form level 2 relationship. Okay, only form layer 2 relationship. They will not form the layer 1 between the areas. Level 1 is only within your areas only. Okay, that you need to be get understanding first before we really go into the advanced. Is that okay so far up to this point? Okay, so these two, all right. Just some of the review to grab some ideas. What is on the ISIS? what is the understanding about on the ISIS. So you need to grab this idea first before I go further. Okay, before I go further. So when I have no question, then I will just continue with the slide for ISIS. Okay, so the first on the advanced feature in the ISIS, we call it as the ISIS conversion. For ISIS conversion, as mentioned, ISIS conversion, they provide a fast conversion. They provide the fast conversion similar to the OSPF. They're also doing the same method as a fast conversion. But under the conversion, how fast they can be converged from the detections until fully converged. What are the steps they're going to go through? First, they need to have a detection. Okay, detect, originate, flooding, SPT, shortest path tree, RIP, and also distribution delay. So everything add up together to get your delay or the time for the full convergence you're going to be passing through from the detected have any changes until you distribute the information. Okay. The first one is on the detection. Detection is the duration from the time when a link fault occurs to the time when the router detects the fault. So how fast I can detect a fault into the ISIS. So it depends on your OSIS algorithms. How frequent they send hello to detect that, oh, they have a failures over days. Okay. So you can based on using the system default method to detect, or you also can use any other methods like a BFD. Can using to speed up the entire detection can be done to detect when you have fault happen inside the ISIS environment. So you can do it on the fast detection. So this is on the duration of the fault detect when the fault happen until the fault detect. How long it take? Okay, that is one of the timers you need to be aware. Secondly, originate. A link status protocol data unit, okay, link state LSP, is generated to describe the new network topology. When detect the failures, I'm going to creating the LSP to inform others. I have a topology change right now. I need to send the LSP. Need to generating the LSP. How long for this LSP be generated is also need to be considered or the converge time. So detection, originated, then flooding. Okay, F, flooding. From the time when the router detect the link fault to the time when the forwarding information base update is sent to the neighbor of the routers. So how long you're going to take for it to flood to the neighbor routers? Okay, how long you're going to take to flooding into the neighbor routers, and how long you're going to take for the calculation for the shortest path tree? This one is normally either ISPF or the PRC. It depends on you add a new node or you just add the route. Okay, then they're going to go for the shortest path tree calculation. How long they're going to take to calculate the path? Then after that, RIP. RIP is on the LSP generated to describe the new network topology. Okay, routing information base. So that is how long they're going to take from the RIP to the FIP. Okay, from the control to the data. How long it take from the control plane to the data plane? Okay, that is on the RIP process. And the last one, the delay advertising route update from the MPU to the LPU. So this is how physically they forward to the LPU. Because MPU is doing the calculation. After calculated, I send this FIP information to the LPU. How long is going to be take for this delay? So for the ISIS conversion can be summarized into this. When you add up everything together, that is the time it takes for the conversions. So they need to include the detection, originate, for flooding, SPT, RIP, and also the distribution delay. So that is all the 6 steps of the delay we might need to consider for the ISIS converge. But definitely for this ISIS converge, it will be slightly faster compared to OSPF. It may be half a second or 1 second faster compared to OSPF. Okay, this on the ISIS converge. Now we look into one by one. How fast of the ISIS perform the link fault detection? So link fault detection can be done by in the normal case. Means that they're using the ISIS hello to doing the detection. So it can be based on 3 seconds, 3.3 seconds, or using 10 seconds of the detection of the ISIS hello. So in the normal case, ISIS link status detect depend only on the ISIS based on the ISIS hello. Its ISIS packet supports second level fault detection, which is inapplicable to the network demand for the fast conversion. To reduce this, use a small interval for transmission, IIH packet. So to speed up, you can adjust the speed of the hello, but that is not recommended. Because let's say you make it more small interval, means that they're going to send more. When you send more, it means that you have a burden for your devices already. Instead of this, why don't we going to use other method? Okay, using the BFD. So BFD usually apply the IP network to detect the link status. BFD support millisecond level detection and it depends from the interface type. Yeah, it can be up to millisecond levels. So the fastest it can be up to 30 milliseconds. So it means that 0.03 seconds they can detect the link failures and alert and perform the fast conversion. Okay, or you based on the interface itself, like SDH or SOTNET, and the Ethernet optical interface support millisecond levels that status detection, provide a higher network conversion speed. However, this detection solution is depend on the interface type, okay, on the post. So this one is more into the transmission environment. This is more into the hardware. Okay, you need to the hardware based on your hardware what you are using. Okay, so BDF is not based on hardware, just on the software. It's just as an application for you to apply into your ISIS to doing the detection. Okay, that is on the link fault detections. Okay, link fault detections. And the next one is on the LSP generation interval. How LSP generation interval that be created from here is to advertise the route 1111. The corresponding LSP must be generated. However, the LSP generation time is in seconds, which does not meet the carrier class conversion requirement. Okay, so let's say you want to have fast conversion, then you might need to be speed up over here, but you will take about seconds for them to generating the LSP. So how are we going to be speed up? Okay, next you'll be going through on this, but from here we need to know the generation interval for ISIS first. If the local route information change, the router should generating a new LSP to notify the change. On the other hand, if the delay is generating and LSP is too long, the router cannot advertise the change to neighbor not immediate. This slow down the network conversion. Okay, therefore we require as an intelligent timer is used for the LSP generation to speed up the network conversion and also maintain the system state to speed up. Okay, setting the intelligent timers. How fast that I can send this information out. Okay, to speed up the network conversion by defining the intelligent timers. So they already have a default intelligent timer. It can be set. Remember just now when you talk about OSPF v3, when you display OSPF v3, they have generated LSA and also the LSA flooding, how fast they can be forward. That can be set on the timers. That is on the intelligent timers. Okay, that's where we can generating the LSP fastest by using the intelligent timers. And the speeding up the LSP flooding. How are you going to flood the LSP fastest? Okay, LSP packet 1, 2, 3. I do not need to wait until all the LSP are received to start LSP flooding. As soon as I receive some of the LSP, I can flood to the out. So immediate when I receive, I forward. I receive, I forward. I do not need to wait for the message to be combined, everything fully exchanged before I send. They provide on the fast flooding on the ISIS. Based on the fast flooding on LSP, according to the RFC protocol, when a router receives an LSP that is generated later than the LSP stored into the local SDB, The router update the local LSDB and periodically flood the update using the timers. Therefore, the LSP synchronization will be slow. Okay, they need to make sure that I store before I forward, store before I forward, keep everything before I forward. So by doing this, we can improve using the fast flooding to improve the preceding method. When a router configured with the features receive one or more new LSP, it flood out the LSP with a number smaller than the specific number before route calculation to speed up the LSDB. So I'm going to say that, oh, you're going to send me to 3, in total send me 3, I'll send 1, I already send first. I do not need to wait until everything come together before I send. I will just, whichever I receive, I forward. I receive, I forward. That is called the speed up on the LSP flooding. Okay, this it can be done to speed up the information. So far, okay? On the speed up fast LSP flooding is called the fast flooding. Okay. All right, so the next one is on the speed up SPF calculation. How are we going to speed up the SPF calculation? This SPF calculation can be speed up by using the intelligent timer as well. Just by right, when I'm going to calculate the SPF information, I have to wait everything calculated before I forward. So I have already flooded out of the LSP to you. Can start to calculate now. So that is on how it defined. So my shortest path first SPF calculation is too slow and I cannot meet the carrier class. So it means that because I have to keep everything before I perform the calculation. And also when you have any changes you send to me, I need to calculate. It means that I need to keep on calculate. You'll be also very busy into my devices. It's a burden to my CPU. Okay, because let's say you keep on send, I keep on calculated. That's why from here they need to using the SPF intelligent timers to detect that should I calculate now or should I calculate later. Okay. Although the route calculation algorithm is improved, but the long interval for the trigger the route calculation also affect the conversion speed. So millisecond level timer can be shortened the interval, but however, if the frequent network change occur, excessive CPU resources will be consumed. Okay, that is also on the drawback why we not set into the millisecond. Let's say sometime when your link is keep on flap. In this case, I can't proceed at all. I need to until I keep on proceed. But after I proceed, you flap again. I proceed one more time. So you just keep on continuous calculating. Okay. So that's why in this case we need to use the STP in the intelligent timers to address this both of the problem. We set the intelligent timers. When you have flapping, then I'm going to slow down. When I have no flapping, I can speed up. Okay, when no flapping, I just speed up. But if have flapping happen, I will just slow down. Okay, you just chill. That when I receive, I just wait for a while. I don't calculate first. Okay. If the topology of the network change frequently, the intelligent timer increase the interval for the calculation to avoid too much of the CPU consumption. That's what I mentioned. So let's say they keep on change. Oh, then I have to slow down already. Let's say there's not keep on changing. Then I can do it immediate by using the millisecond levels. I can do the calculation immediate. Okay, that is how we speed up the SPF calculation by using the intelligent timers. So whichever I mentioned over here, they will also support using on the OSPF. Okay, also support on the OSPF. So it's not only from one direction. OSPF also doing the same information as well. All right, and next. Is on the adjustment or adjusting the calculation method, the SPF calculation method. So they're using the ISPF. Okay, calculate only the change route at a time rather than all route. Okay, so only one route, only the change route. During the first calculation, I'm doing all the route at time. Okay. I was doing all the nodes. After that, only route on the affected node will be calculated each time. So for the first, I need to do all nodes. Okay, that is the ISPF. Okay, ISPF. For similarly to ISPF, only change part of the consideration in the PRC. Okay, the partial route calculation. But however, PRC does not calculate the shortest path, but update the leaf route based on the SPT calculation by the ISP. Okay, so we need do the calculation based on the path that have been modified. The route has been modified, but it's not all. Modifying a broadcast network to the point-to-point network reduce the number of pseudo node on the network and shorten the SPF calculation. Now that is a true statement over here. In ISIS, normally we're not using broadcast environment. Same to the OSVF as well. We do not use broadcast environment. But they detected as a broadcast, they have no choice because of, in this case, let's say they're using Ethernet. They're using Ethernet. When using Ethernet, it means that this is a broadcast already. When broadcast, they need to send to the DIS. So it means that they do not need to keep on sending this information to the DIS to shorten the calculation time. Do not need to deal with the DIS, just purely the DIS. So in this case, it's not that important. So by doing so, we can adjust this, change, set the ISPF, set the PRC, and try to change all your broadcast network to become a point-to-point network. So that is what the recommendation that we can provide to speed up the SPF calculation method. Okay, using the ISPF, PRC, and modifying your broadcast to become point-to-point. When point-to-point, it means that they have no DIS already. Is that okay? Based on what I explained over here? Any questions so far? No problem. For this adjusting. Next, on the ISIS fast conversion configuration, and this is how we perform on the configuration. On R1 and R2 are interconnected and they communicate with each other through the ISIS. It is required to improve the conversion speed of the two routers through the BFD. Okay, so over here I have done this. I specified only the level 1, level 2, IS level 2. So it's a good choice as well. Since that it's only point to point, there have no point for you to send level 1 LSP as well as level 2 LSP together. There's no point. So why you need to send both of the LSP? So why don't you just send one levels? Because it's only point to point. So you can using just a L2, set the L2. Okay. A timer LSP generation 11120 level -2. So you change the level 2. So this is all in a second. And fast the flash flood, the flash flooding on the level 2. Okay, flash flood on the level 2 and never entities followed by the timers, SPF, to speed up the intelligent timers. Okay, this is on the intelligent timers. Intelligent timers. Okay, this is on the LSP generation. How fast they can generating the LSP. So maybe I over here give you some detailed information because it's not inside the materials here. You just bear with me a while. Let me just show you on the timers LSP generations. So this is how you show from here on the timer LSP generations. So a bit too small. Okay. So from here, they're going to set at the timer LSP generation, maximum interval, initial interval, incremental interval under level 1 or level 2. So this is on the LSP generation to configure intelligent timer for the generating the LSP. How fast they can generate things. For the maximum interval is based on seconds. Okay, based on seconds. If the default value will be 2. So in this example, in my example over here, I said that I have 1 second. Okay. For the initial over here is under the milliseconds. Okay. Specify the initial delay in the generating the LSP. Specify the incremental delay into the generating the 2 LSP with the same LSP IDs. Okay, when they have same. So the value also here is also under milliseconds. Okay. So from here, I will say that from 1 millisecond up to 120 milliseconds. The initial will be 1 millisecond, the fastest already. And for this is to combine. I said that 2 LSP with the same LSP IDs. I wait a while. How long I can wait for? I will wait until 120 milliseconds. And this work on the level 2. It's run on the level 2. Okay. And same things on the timer SPF. Okay. This is on the let me just show from here. The timers SPF. Okay, maximum interval, initial interval, and incremental intervals. Okay, so this is how they're set. Okay, so from here it be 1 second, 20, 100. Okay, the first is 1 second, second is on the millisecond, third is milliseconds. Okay, from 20 to 100 milliseconds as an incrementals for the timer of SPF, how they perform the calculation. Okay, the calculation of the timers, and the flash flood on the level 2, how they provide the fast flooding on layer 2. Okay, that is on the timer that you can define under ISIS. Okay, that is on the ISIS configuration. It can be speed up the fast conversion. So from here, you need to know some of the command from here, because in the lab exam, they might ask you on this as well. How they perform the LSP generation, or how they perform the SPF calculation. Okay, SPF calculation, that is the one. This SPF calculation. This is how fast you generating the LSP. When the fault happen, how fast are generated and sent to the peers. Okay, that is you enable the fast flooding. And next is on the BFD. BFD is one of the protocol to doing the detection to detect the failures happen between the link. Let's say have failure happen, then I'm going to give you the alert through the BFD. Okay, BFD A to B, binding peer IP 10.1.1.2, interface 101. Okay, 101. Then I have a peer IP address of 10.1.1.2. Okay, this is a 10.1.1.1. Okay, I do detection between this direct connected. Then I ISIS BFD static. So this static will be appointed to this BFD that I built. Okay, using a static BFD. So they can also using a dynamic ISIS BFD. So it's up to what method they're using. Okay, so in this case, that is what they define. Default is the 30 milliseconds. Okay, 3 times. Every time 10 milliseconds. Every 10 milliseconds, I will send hello to you. Let's say you reply back to me, Miss Abia, okay. But let's say 30 seconds and not receive any hello from you, I consider you are down. That is called the fast conversion inside the detection. How we can detect, perform the fast detection by using the BFD. It's under a millisecond level of the detections. So far, alright, that is on the fast conversion on the ISIS. This is on the advanced features. So the next one is on the administrative tag. Administrative tag. This is also considered as a route tag. Okay, as a route tag. For this route tag, it's just like how I'm going to be assigned the tag information from the left to the right. So I can say that, oh, this tagging, when I import route from this OSPF, I need to give an administrative tag to tell that, oh, this all belong to the OSPF. I have one tagging to recognize that, oh, this traffic is come from the OSPF or come from the BGP or come from a static. I need to do some identification where this route come from. It's come from one of the protocols. Okay? This can be done by using the administrative tag. So for this tagging, based on the basic features over here, administrative tag control the advertisement of the IP prefix in an ISIS routing domain. To simplify route management, you can use the administrative tag to control the import of the route of different level and different areas and control ISIS multi-instance running on the same routers. That is where they come from. So that is the benefiting by using the administrative tag to do the tagging, to identify where you come from. So before I can easily handling you, I can know that, oh, you come from here, this is how I handling your traffic, okay, based on the tagging. And the value of an administrative tag is associated with a certain attribute. When this cost style is wide compatible or compatible, and ISIS advertise an IP address prefix with this attribute. ISIS add the administrative tag into the TLV in the prefix. So they only can support within these three cost style: wide compatibles and also compatibles. Okay, so the cost style by default is narrowed. Is a default cost style. So it means that administrative tag does not support under the narrow cost style. When you want to use the administrative tag, you have to shift your cost style to wide. And this normally what we are using as a wide cost style. When you configure ISIS, the second step we perform after the network entity, we're going to change the cost style to wide cost style already. Okay, that is what normally that we perform. Okay, on the basic features here. And next on the working principle, that how it defined from here. So I have a L1, L1, L2, L2, L1, 2, L1, L1. So you can see that I have two different segments over here. Okay, two different segments. R1 need to communicate with R2 in the area 2. However, to ensure that information security, routers in the area 2 cannot receive packets sent by R1. First, you can configure the same administrative tag for ISIS interface on R1 and R2. Then, level 1, 2 routers of area 1 link only route match the configuration administrative tag from level 2 to level 1 areas. In this way, among all the routers in area 2, R1 only communicate with the R2. So how are you going to do this? By using the different tagging. Okay, you're going to tag. You configure the same tag for the ISIS interface on R1 and R2 using the same tag. Then, when on the level 1, 2 routers under area 1, I leak only this information into the level 2. Okay, only same thing, I only leak this information into the level 2. So I only allow this to be passing through between the areas. So in this case, router 1 and router 2, you'll be able to communicate only themselves. Okay, like this. After the administrative tag is applied, R1 is in area 1 can communicate only the R2 in the area 2. By setting the tag, setting the tag is not only the things. You need to also make sure that your level 1, 2 is doing the filtering. I'm not sure that you still remember on the route leaking, how you're going to be route leaking between the way they mentioned that, how you're going to route leak from one end to the other end. Okay, how it can be defined. So later we might need to go through this a bit on the route leaking as well. When they have using the tagging, how we can tag, how can we route leak only the tag information. Okay, so this is all also related to the route leaking. So far, okay, for the working principle on the administrative tag, to classify, to identify who you are before I can filtering the information. Okay, I can filter only you going to the area 2. I also only filter router 2 can only go to the router 1. So I'm doing the both way filtering by using the tag. Okay. And the next one is on the ISIS LSP fragmentation. So this fragmentation is only happen that, let's say, because every single LSP that you send, they have a limit. You cannot send up to a certain limit. When you have up to a certain limit, I need to do a fragmentation. Just like our IP packet. IP packet, when they exceed the MTU size, I need to perform the fragmentation. Okay. Similar things into the layer 2 ISIS. Okay. Under LSP fragmentation. Okay. For the basic term over here, so you need to get the ideas. Under the, we have originating system, normal system, virtual system, and also additioning system IDs. So under the fragmentation, we need to grab the ideas what is called originating system, a normal system, virtual system, and additional system. The first one, originating system, is the router that run ISIS protocol. A single ISIS process can function as multiple virtual routers to advertise the LSP. And the originating system refers to the ISIS process, which process you come from. Okay, that's called the originating IDs system. Normal system ID is a system ID of the originating system. So where it come from? This is your system ID. The 6-byte system IDs. Virtual system is a system identified by the additional system ID to generate extended LSP. Let's say you're going to send the fragmentation, you're going to use a virtual system for you to send it out. And these fragments carry additional system ID in their LSP IDs. Okay, they need to identify inside the LSP ID, I'm the virtual system that I send this information as a fragment. Okay, additioning system ID assigned by the network administrator to identify a virtual system. A maximum up to 256 extended LSP fragment can be generated for each additional system IDs. Okay, means that every single thing I can only handling 256 LSP fragmentation. Okay, it means that it's about, in total I can generating about 13,056 LSP fragment I can be generated. Okay, under the additioning system IDs. So this is on the basic term you need to grab the ideas. The OS, NS, VS, and the AS. Originating, normals, virtual, and also additionals. Yeah, let's have a look how the working principle it works inside the fragmentation for the LSP fragmentation. So they have a limitation from here. Is the ISIS in each system ID identify a system which can generate a maximum 256 LSP fragment only, maximum up to 256, which with more additional system ID, up to 50 virtual system can be generated, and ISIS can be generated a maximum up to 13,056 LSP fragmentation. Is that okay? So that is the 256 you times 50. Okay, 13,000 at 056. So after the LSP fragment extension is configured, the system prompts you to restart the ISIS process if the information is lost because of LSP overflow. After being restarted, the original system load as much routing information to the LSP and add the overload information to the LSP of the virtual system for transmission, and use the TLV24 to notify the routers with the virtual system. So it means that when you're going to enable this LSP fragmentation, I'm going to be restart the sections, and after that I restart. It depends on how many virtual system you're going to be built. Okay, for you to sending all the different LSP, I can build up to 50 virtual system. Okay, 50 virtual system, but every single virtual system I can be only handling 256 LSP fragmentation. Okay, every single virtual system only up to 256. When more than that already, you need to create another virtual system, one by one. Let's say you have more than this fragmentation need to be forwarded, and something like this. So that's how the virtual system look like. Okay, virtual system A1 and A2. So over here I can handle 256. Over here I can handle another 256. Okay, that is how they're going to be sent more LSP when they are not sufficient anymore. They're divided to mode number 1 and mode number 2. On mode number 1, some router on the network do not support LSP fragment extension. And mode number 2, all router on the network support LSP fragment extension. Okay, when they are not supporting, then I might need to have this virtual system to tell you that, oh, it's come from another routers. It come from another system. It's not come from me. It come from another system devices. In mode number 2, virtual system that do not participate into the SPF calculation. All the routers on the network know the LSP generated by the virtual system actually belong to the originating system. Okay, but for the mode number 1, they need to calculate, go to the virtual system. So it means that when I collected this, I need to calculate for this is go to this system. Okay, it's go to this system. When it's not everybody know about the LSP fragmentation, but when everybody know, then you do not need to calculate up to that. You just calculate up to router A will do, because it's just a router A sub virtual system only. Okay, that is a 2 different mode. So it depends on your environment. Either you are using mode 1 or mode 2, just compare between the device. Do they support on the LSP fragmentation or not? They say they do not support, then you have to using mode number 1. They're going to calculate the SPF, go up to the virtual system. With mode 2, they just calculate up to the direct connected, the originating system IDs. Okay, up to this. This is on the mode 2. This is on the mode 1. Okay, there's a difference between the two on the working mode when define the LSP fragmentation extension features. Is that okay so far? That is on the 2 way of the working mode inside the LSP fragmentation. So the next one is on the ISIS route filtering. How you perform the filtering on the ISIS route? So ISIS route will be very similar that we filtered from the OSPF. Okay? From the OSPF. ISIS route filter calculated based on the LSTB. So that's what I mentioned is the same. By configuring ISIS to filter route calculated based on the LSTB, you can control the number of ISIS route to be added to the routing tables and reduce the size of the IP routing tables. Okay, and this is first when you're going to do this, how you're going to control this. First, configure ACL or IP prefix. These are the 2 things normally we define to perform the control of the filtering. Okay, ACL, then configure the filtering. Filter policy, ACL name followed by import. So always we do not filter outgoing, only filter incoming. Is that okay? Only import you can filter. Okay, no filtering like OSPF. OSPF you still have LSA can filter because we have API and ASPR. From here, they have only 2 LSP, so it's difficult for you to filter in this case. You can't recognize which one is which one. So it just only can be used on the filter policy import to filter the ISIS information. So far okay for this filtering calculated based on the LSTB. Okay, you only can doing the filter policy import. Whichever you filtered already, it means that I will not based on this to do the calculation. I will not do the calculation based on what you send to me. Is that right? ISIS filter on the LSTB. Only import can be done, no export. And next, secondly, is a router A and router B establish an ISIS neighbor relationship. Router A can learn a route to be loopback 1. Router B through ISIS. How you can perform on the filtering? Okay, router A can learn a route to the loopback 1 on the router B through the ISIS. Before the filtering, F100.1.1.1, ISIS level 2, 15, 10.1.1.2. Okay, so next, router AB establish ISIS neighbor relationship. A traffic policy is deployed for ISIS so that the routing table of router A does not contain the route to the loopback 1 and router B. But the route to the loopback 1 of router B exceed inside the ISIS LSTB. So database is still there, but I just do not want to allow you to go to the destination. So what I'm going to do here is, First, I define the ACL. Rules number 5, deny source 100.1.1.10. That's what I filtered. And ISIS 1 and say that filter policy ACL name Huawei import. Whichever import I receive, I'm going to look into the ACL. Oh, this address 100.1.1.1, I do not calculate. I will not calculate on this destination at this source. Then I will just proceed. Okay, I will not based on this to do calculation. So after you're done on the filter policy, you should see this result. You should see the result of the 100.1.1.1 will be missing from your routing tables. But your database is still having this information. Just that you do not take calculation on this only. You will not do any calculation to the destination of 100.1.1.1. Okay, the route is filtered, but the LSP is still inside your database. Okay, that is how we perform the filtering. So far, okay. An ISIS filter imported route. Okay, the route that imported into the ISIS, that what it can be filtered. You can configure ISIS to filter imported external route to effectively control the number of ISIS route on the network. Okay, so they're using the IP prefix, route policy, permit node, if match ACL or if match IP prefix. So they have two choice. So it means that when you imported already, when you import, I'm going to filter the information. So that's what you can do. Filter the imported route. Okay, the route has been imported into ISIS, and how can I filter this? I can using the filter policy as well by using the ACL or using the IP prefix. They have two options in this case. And router A, B establish ISIS neighbor relationship. Router B can import a direct route to the loopback 1 to its ISIS LSDB and advertise the route to the router A. So, okay. So I've imported into ISIS and sent to the router A. So I learned this. Okay, 100.1.1.1/32. So in this case, I want to filter this information go into my ISIS. I do it on router B. I settle on the router B to perform the filtering. Okay, on the router B. So I do this. IP prefix is called Huawei in text 10 deny 100.1.1.32. Okay, and from here, route policy Huawei deny node 10 if match IP prefix Huawei. Import route direct route policy Huawei. Okay, so in this case, I will not allow this to be advertising. But in this case, you're doing this way, it means that you not allow anything. You are not allowed anything at all. You just deny everything already. So let's say doing a proper way, you only want to filter 100.1.1.1. What we should do? We should do it like this. We should do it like this. Let's say you only want to deny one and allow the rest. So you should do this. IP prefix Huawei deny. It's okay to deny 32 and follow another permit 0.0.0.0.0 less equal 32. You need to allow the rest. You cannot say that I only want to deny one. Because by default, you deny one, the rest will be denied as well. Just some sort of you having the implicit deny. Same case to this. Let's say you do not want to using this method, you can using this method as well. Route policy, you add another policy. Huawei permit node 20. Leave it blank. At least you allow the rest. You just only deny one of the address, the rest you are permitting. So you have two options from here. Better you using this method. Better than this method. With this method, you will just deny everything. not only deny the address, you deny every single addresses inside your router B that you imported. So in this case, actually, you're just not doing any import route. Do you get what I mean? You not import anything. Then actually, it can just ignore this command. You're not import anymore. Why you going to use this command to deny everything and you import route deny everything? So for me, it's no point. Okay, let's say you want to only specify one address to be denied, so you better to put another node as a permit, node 20, to allow the rest that is not match the rules. Okay, so that will be the way of how we import information into it. Okay, in this case, you just deny everything actually. So that is not recommended. So after I've done this, you can see that 100.1.1.1 you never show from the router A already. So they're totally removed from the router A. Is that okay? So far, any questions? All right. So the next one is on the ISIS filter external route when they are advertising. Just now is before they come in to the ISIS I filtered. Now it be when they're inside the ISIS already, I filtered before I send to you. Okay. ISIS filter imported external route when they are advertising. Configure filter policy for external route that are to be advertised. Filter policy can based on ACL, can based on IP prefix, can based on route policy, and the keyword as a export. When I export to you, that is what I need to filter. So this has to be do it from where? Do it where you import route, where you done the import route. Okay. Same case. Router A and router B establish ISIS neighbor relationship. Router B import direct into the OSPF. Same situation. I import to the ISIS. Router A learn the route. That's good. I learned the route of the 100.1.1.1. That's all good. But how are you going to perform the filter when they are inside the route? Okay, and this is where we can perform here. So the import route direct is still remain. You import everything and you filter this only. IP prefix Huawei Intex 10 D900.111.32 filter policy ACL number Huawei export. Okay. So when I'm generating this LSP out, I filtered already. So this LSP will be not generated for 100.1.1.1. You will not be sent to the router A. Is that okay? And this will be the result and why they are not receiving the information. Okay? Why they're not receiving the information, that is how the result comes from. Is okay? So the next one is on the ISIS route leaking. So what's the function of the route leaking here? All right. For this route leaking, maybe I'm going to just do it together to you. Yeah. We can configure together. I will show you the lab, then we do it at the same time. Is that okay? Let me just show you the lab first. Give me a second. Let me show you the lab. Okay, let me start this first. I will share you this information, then we can show and do it together. Okay, a bit slow. Hold on. Just let me just start everything. So let me share you this file, then we can do it together as a route linking. I will share it into the WhatsApp. So did you receive already for the route linking? You can after receive, you just open up. I need to just open. I just need to open one more time because this one is on the V6. I want to show you the V4 first. So after you download that, you can just start on the lab first. I'm starting on my side as well. So while waiting for this, let me just show you what are the problem, why this route leaking is important. So actually, this is what I also keep on mentioning. So from the routers over here, okay, this is on the two area, 49001 and also 49002. Okay, so this is a level 2, this is a level 1, this is level 1, 2, and this is level 1, 2. So as I mentioned before, for level 1, level 1, go to the level 2 destination that going to 4444, which path I'm using. How am I going to use the destination go to 4444? Remember, L12 only translate level 1 level 1 to level 2. That only they do a one-way translation. They will not doing on the white versal. So from 2, you never go to 1. It means that level 1 routers, you will never get a detailed route of 4444. Never. But in this case, how the router A go to destination? They're based on the level 1, 2 routers. Level 1, 2 routers give a default route back into the routers A. Okay, it give a default route to him. Okay, it keep a default route, it keep a default route. But for router A to define, then compare the cost. Cost of 10, cost of 20. Which one better? Cost of 20 is better. Cost of 10 is better. So I'm using router B as a next hop to go to the destination. But in this case, you found that they go for the suboptimal way already. From 10, 30, and 20, 10. Which one is better? Definitely going through A, C, D is better. But now, because of the default route they provided by router B is cost of 10, default route provided by router C is cost of 20. Only check the first hop. In this case, they select this path. So they're going to the suboptimal way. So how the route leaking can be solved the problem to allow router A can go to the destination by using the better path. Okay, how are they going to perform this? They're using the route leaking to leak the route from L2 back to L1. From level 2 back to level 1, then in this case, they are able to access from router A to router D. Okay, that is on the route leaking by using the ISIS. Okay, this is the concept, okay, that I want to go through with you. So now let's check on the configuration. Is everyone already started ready? Okay, fully started. So from here, I will just open up the routers. Okay, router 1, 2, 3, 4. And before that, let me just clean up a bit. Okay, display CC ISIS. Okay, ISIS is not defined yet. So over here, I'm going to show you that how the ISIS is being configured. Let's follow me together how to configure the ISIS. So right now we configure only on the IPv4. So tomorrow we're going to configure IPv6 or ISIS. So for router number 1, I belong to level 1. Okay, this 2 is the level 1. Router 1 and 2 level 1. Router 3 and 4 is level 2. Level 1, 2. Router 5 is level 2. Okay, so I will show you the configuration from here first. Check on the IP address first. They should have all the address defined already. Okay, nothing to read. So the configuration is very similar to the IPv6. That's what I define here. On router number 1, ISIS 1. Network entity, okay, 49.001.000.000.001.00. IS level 1. Okay, and then interface gate 000 ISIS enable 1. Interface gate 001 ISIS enable 1. Interface loopback 0 ISIS enable 1. Okay. That is on router number 1. Okay, I will just hold here for 30 seconds for you to copy. Okay, done. Do it on router number 2. Router number 1 configuration is over here. You can just copy the configuration from there. So router number 2, it be same step. I need to define ISIS 1 network entity 49.001. Okay, IS level 1. Interface gate 000. ISIS enables 1. Interface gate 001. ISIS enables 1. Interface loopback 0. ISIS enables 1. Okay, that is for the router number 2. Okay, this is router number 2. Okay, router 3. Router 3 is very simple because its default is the level 1, 2 already. So you do not need to change. I will just need to set the network entity ISIS 1 network entity 49.001. Okay, interface gate 00 ISIS enables 1. Interface gate 001 ISIS enables 1. Interface loopback 0 ISIS enable 1. And interface 000 I need to put ISIS cost 30. Okay, let me set this. Okay, this is on router number 3. Router number 3 do not need to set the IS level. Default IS level 1, 2. Okay, that is on the router number 3. Same to router number 4. Router number 4, I will have ISIS1 network entity 49001. Okay, interface K001, ISIS enable 1, interface K002, ISIS enables 1. Interface loopback 0. Okay. Yeah, this is on the router number 4. Router number 4 do not need to set the cost. Nothing to set on the cost. Okay. And the last one, router number 5. Router number 5 a bit different because it belongs to another area. It's a 49002. So over here, be careful when you define this. It's under next areas. So I put ISIS1 network entity 49002.000.005.00. IS levels level 2. Okay, and followed by interface gate 000 ISIS enable 1. Interface gate 002 ISIS enable 1. Interface loopback 0 ISIS enable 1. Okay, that is on the router 5. Okay, Okay, they're router 5. So that is all the configuration need to be done. So I just wait for a while for you to complete on this before I show you the result. Okay, I give you 1 minute to just make sure you have done everything. Okay. All right. So in this case, let me check on router number 1. Okay, on router number 1. Under router number 1, how we define how to go to 5555. But before, let's check display IP route protocol ISIS. So do you see that? Can you go to 5555? No, but I have a default route. The default route point to who? Point to 10.1.13.3. Okay, so I can ping to 5555. Not an issue. I can do a tracer to 5555. It's going through router 3 and router 5. Okay, that's all good. But over here is cost of 10, cost of 30, cost of 40 in total. But below is cost of 10, cost of 10, cost of 10, cost of 30. So 30 and 40, which one you prefer right now? By right, you should prefer 30. Because of R1, they do not learn 5555 as a detail. It only depend on the default route. Default route tell me that this is a 10. So I define this as my best way. I will not select the bottom path as my best way. So in this case, let's say you want to allow them to go into it using this way. What should I perform in this case? So I'm going to use the route linking. A route linking from the one side back to the other side. Perform the route link from level 2 into the level 1. We can go and router 4 and have a look. Router 4 display IP route protocol ISIS. I did receive 5555. I learned as a level 2. Yeah, I learned as a level 2. But this information you will not share to router 2 because level 2 information you will not fall back to the level 1. Only one direction, level 1 to level 2, but not level 2 to level 1. So in this case, what I'm going to be shown from here is I need to do it, let's say do it on router number 4. Do it on router number 4, I said that in ISIS 1, import route ISIS level 2 into level 1. Okay, from level 2 into level 1. Import from level 2, import into the level 1. Okay, after I'm done on this, let's check. I check on router number 1. After I import already, check from here. 5555 is in my routing tables already. And this is the cost of 30. This is where I'm using to reach to the destination. So this is called the route leaking. Leaking the route from level 2 into a level 1. Okay, that is what we can perform into the ISIS. Because of the limitation, they mentioned that whichever on the level 1, 2, I only do one-way translation. I only translate level 1 to level 2, but not the other way around. So that's why this will be the drawback. For the calculation on the level 1, they cannot get the exact best path going to the destination. In this case, they have to use the default route. Okay, so to solve the problem, we need to perform the route leak the level 2 into level 1 to perform the calculation. But the one that I use just now, I will just import everything into the level 1. That is also not good as well. Let's say anything you want to prefer, you can just using the more specific by using the prefix list or using the ACL. Yeah, let's say right now I'm doing this. I only want to set that. Let's say right now we quickly do it over here on router number 5. Interface loopback. I create another loopback 1. Okay, IP address for 55.1.1.1 24 or 24 32. Okay, let's say 32. Yeah, 32. So in this case, what I'm going to do, I'm going to do ISIS enables 1. Okay, so we're advertising already. So by right R1, it should receive this as well. 51.1.1.1. Okay, but now I do not want allow this using the route leaking. I want to R1 go to 51.1.1.0 using the path of the R3 instead of R4. Okay, using R3 instead of using the R4. So what I can do in this case, so I can set the prefix list. Set the prefix list filter whichever that allowed that coming in. It's okay. So I'm going to do router number 4. I build a prefix list first. IP prefix. Okay. Net 5. Permit 5.5.5 32. I only permit this segment into the leaking, route leaking from level 2 to level 1. Okay, level 2 to level 1. So what I can do from here is, after I've done this, I go back to the ISIS 1. Import route ISIS level 2 into level 1. Filter policy IP prefix net 5. That's what I only allowed to go. The rest is not in the list. They will not sending across. Okay, let me go back to R1. Check one more time. You see that 55.1.1.0 is no longer here. Yeah, 55.1.1.0 is no longer here. Only left the 5555. Can I see that when I do a tracer 5555 and tracer 55.1.1.1? So you can see that that is how it works from different directions. One is on the top, one is on the bottom. Is that okay? From the route leaking. You also can do it on both sides. Actually, you can do it on R3 as well. R3, you also can perform the same step like doing this. IP prefix net 5 permit 5555 32. Okay, and I go to ISIS 1, import route ISIS level 2 into level 1. filter policy IP prefix net 5. Okay, but on router 1, you will see this or not. On router 1, you only see one bus only, because this is a 40, this is 30. I will not define the calculation in this case. Okay, let's say I want the redundancy, it's better it be the both way on the route import. That can be on one way as well. Let's say you want to do it in this case. So that is on the route leaking. This is what I want to show you, that how this route will be leaked into the level 2 to level 1. Is that okay so far? Alright, so that is on the lab on this route leaking. So it's just to do a showcase to show you that what it means by the route leak over here. Then come back to the slide from here. This is a route leak number 1. They're going to set the cost. That is the cost of 30. Okay, this cost of 20. So I have 10, 30 is total 40, 20, 10 is 30. But in this case, for the route leaking, they always prefer that as the best path. By doing so, we need to do this command. It's called import route ISIS level 2 into level 1, level 2 into level 1 to route leak back into the level 1. From level 2 to level 1, level 2 to level 1. Okay, to do the leaking on the level 1, 2 routers. So after I route leaking already, router A will do the calculation of using the cost of 30 instead of using the cost of 10. Okay, this is the best way for them to going to the destination by using the cost 30. So far, okay for this on the route leaking. Questions? Okay, so I think for today I will up to this point. Tomorrow I will cover on the basic principle and configuration of the IPv6 ISIS. For today, we cover OSPF, OSPF v3, as well as ISIS version the IPv4 advanced ISIS. So tomorrow morning section we will finish on the IPv6 ISIS and followed by a BGP protocols. For BGP, we'll cover 2. It's a basic BGP and also the advanced BGP. Yeah, that's what we're going to cover for tomorrow. Okay, for today, I will just up to this. But before you leave the training, do you mind that just wait for a while? I capture the attendance. Okay, hold for a while. I capture the attendance first. All right, so that's all for today. And tomorrow we'll continue with the IPv6 ISIS. All right?
Okay. Sure.
Okay.
Thank you, sir.
Okay, thank you.
Thank you, thank you.
Can you share the configuration route leaking?
Yep.
Okay.
Thank you, Nick.
Thank you, thank you.
Thank you.
Thank you, thank you. See you tomorrow. See you tomorrow.
See you tomorrow. Bye-bye.
Bye-bye.
Bye.
Thank you very much.
Thank you. Bye-bye.
Thank you, Mr. Lee.